Welcome, dear listener. I wish to present a brief yet curious and hopefully stimulating collection of ideas knitted around a complex topic. I have decided to cut the presentation into 6 different concepts or vague hypotheses. The topic is abiogenesis, so here goes with hypothesis number 1. Life begins on the Earth. Well, to be honest, I don't have a picture of the Earth 4 billion years ago, but with a bit of help from some artist, there we go. Thank you, Mr. Artist, that's much better. Now, you might know that the universe itself is 13.7 billion years old. The Earth and the solar system are around 4.5 billion years old. This means that stars have been cooking up heavy elements for 9 billion years before our solar system even turned up. Now, conventional astronomy, as done for the past 100 years, uses something called spectroscopy. And using spectroscopy by splitting up the light from stars and that absorbed through dust clouds, we know for a fact that there are complex molecules throughout the galaxy. These are the results of just plain old chemistry with some energy. There are both organic and inorganic molecules, which are usually found in things called molecular clouds. For example, the Orion Nebula is a molecular cloud. There is another one called G43.3, which is quite unique in the fact that it's made of 100% alcohol. It's about 1,000 times the diameter of the solar system. It's about 300 light years away or so, if I can remember rightly. And there's enough molecular alcohol there to give every person on the planet 300,000 pints of beer every day for the next 7 billion years. That's a lot of alcohol, even if you're Irish. I don't think I should have said that. Other abundant molecules include sugar, guanine, methane, carbon dioxide, water, cytosine, and a plethora of other molecules I haven't really the time to mention. Now, if these molecules exist throughout the galaxy, which is quite close to us as well, they surely exist in our early solar system too. Just look at what we found on the Saturnian and Jovian moons. Apart from the organic ones I've mentioned already, very complex chemicals indeed. In fact, the moon Europa of Jupiter is said to have very, very deep liquid water oceans underneath its icy crust, although the gas giants themselves are mainly hydrogen and helium. Looking at Mars with its carbon dioxide atmosphere, the same or similar organic compounds on its surface and within its soil, especially the water that's there and has been there in the past. And we look at Venus, which has similar organic compounds, although it does have sulfuric acid raining down all the time. And as yet, no dinosaurs found. Shucks. Now, on the early Earth, there would have been a lot of energy available to make these molecules break apart, come together. There would have been plenty of abundant energy as well, due to lightning storms, plate tectonics, volcanism, and of course UV light, because in the early Earth there was not that much, if at all any, oxygen in the atmosphere, so there was no ozone being made. So electrochemistry was going on all the time in the shallow oceans. So given enough time, say 500 million years, there might have been a very good chance that RNA could have formed quite easily without any assistance from anything else. So it could be quite feasible for small strands of RNA to come about. Not thousands of base amino acids, but groups of 3 or 4, 6 or 7, 8 to 10. These would replicate by using molecules from the organic soup in the oceans, and therefore replicating itself. Indeed, the Nobel laureate Harry Kroto reckons that RNA is probably the best hypothesis for life starting on the Earth. So there you have it. Life originates on the Earth due to the chemicals already available that we see now throughout the galaxy, and given enough time, water and energy through volcanism, electricity, discharges, and UV light. Oh, and before those people say, how do you get life from non-life? What do you think you're made of? Atoms. Would you call those life? No, so that's over. Shut up. I think the odds of that happening are pretty much even. So there's part 1, or hypothesis 1. 2, or hypothesis 2. Life comes from interstellar origins. So from molecular clouds again. These molecules, complex and otherwise, managed to get here after the Earth had formed, within the first 500 million years, when it cooled sufficiently for these molecules to take hold in the seas. And of course the Earth was being heavily bombarded at that time, probably by a lot of comets, as well as asteroids, meteors, etc. and they would have brought a lot of other chemicals, molecules, and water. And the atmosphere of the Earth at that time would have been heavily carbon dioxide rich, and not much oxygen at all. So again, similar odds to what we would expect with life originating on Earth, because basically it is the same material. Now we go on to number 3, accidental panspermia. We find meteorites on Earth, like in Antarctica because they're easy to find on top of the snow, that originally were parts of another planet, such as Mars. These bits of Mars have got here through Mars being impacted by an asteroid or other heavenly body, and some of the bits flying off manage to leave the orbit of Mars and eventually end up either tens of thousands or millions of years later crashing into the Earth. Now imagine the same things happened on a planet outside of our solar system where it's been hit, where life already exists, and some of this life has hitched a ride on part of the rocks or seabed it was living on, such as simple bacteria, and that goes into orbit for 10,000 years, or out of its orbit for 10,000 years, and eventually arrives on the Earth, and then it flourishes because you've got ready-made DNA, which then evolves due to environmental pressures here on Earth. Again, the odds here, bit slightly more than evens, about 1,000 to 100,000 to 1. However, if this did already happen earlier in our solar system's evolution, the meteorites from Mars might have contained early life because Mars might have been better suited for early life than the Earth was, less violent, bit cooler, and we could all be Martians. Number 4. This is what I call planned panspermia. Not quite chariots of the god stuff, but an alien race launched simple life forms like viruses or bacteria into space and aim it at certain star systems hundreds of millions of years before our planet even started off. And these cells, some of them, managed to get here, and then they'd be under the same evolutionary and environmental pressures while on Earth and evolve into forms which would flourish on the Earth. Odds here, 10 to the power of 9 against. 5. Engineered panspermia. 4 billion years ago, a group of hyperdimensional aliens from another part of the galaxy visit the primordial Earth, either in person or remotely. We'll say in person. They decide that the Earth has a chance of harbouring life, so they make and transplant simple cells of their own into our seas. Then they leave to see what happens. They would not necessarily come back to have a look, but they would be monitoring the planet quite closely on remotely, looking to check for oxygen and ozone in the atmosphere, much as though we're going to do with extrasolar planets to try and find an Earth-like planet. Why do I think they wouldn't return? Well, they were probably on a mission going to thousands of planets over millions of years, and so they wouldn't want to really waste the time, the effort, or the resources on coming back just to check on this bit of rock. Odds against, about 1 trillion to 1. And now for number 6, the evil Empire Panspermia. A huge alien population seeds the Earth 4 billion years ago and returns every million years or so to check on how the evolution of their cells they put on the Earth is proceeding, and they nudge it and change it all the way through, change some of the new life for their own populace. This is much sort of in Daniken Scientology sci-fi, I suppose, but they come back and they check, and they do it in person, but they do it invisibly so we don't know, and they're guiding our own evolution right up until today, and giving us subliminal ideas on how our science will work, and probably keeping stuff from us as well. Like landing in Arkansas or something and just selecting the odd farmer and transplanting bits of their DNA onto their mothercraft, lifting off and going away again. The odds for this, I suppose, are a bit balmy. Say 10 to the power of 20 against, at least. So is this the balmiest of them all? Well, hold on, let's think about this. Virtually supernatural beings guiding the life on this planet, supernaturally telling us what to do and how to do it, by methods our science can't measure. Sounds pretty familiar to me. What about you? Not forgetting number 7. Oh, and before I forget, this is for Bob. There you go, Bob.